In this video, I'm going to follow up the statistically significant omnibus effect associated with the exposure study that found that the means were not all equal to each other. So from exposure 1 to exposure 25, there's at least one mean comparison that is statistically significant, but we don't know which one. We just know that there is at least one. And as I mentioned in the textbook, there are very few options to conduct multiple comparison procedures in SPSS. I wouldn't say SPSS is unique that way. There's just not as much research done in this space. So I'm going to show you the couple of options that exist. And if you go into options here, first I'll point out again that if you click on post hoc, you won't get any options at all. And that's not a mistake. You haven't done anything wrong. That is just because you do not have a between subjects factor in this analysis. Only once you have a between subjects factor will this button become usable. You do have options though as a button, and click exposure and put it in display means for and compare main effects, and you've got LSD, Bonferroni, and SEDAC. We can't do a protected Fisher's LSD because we have more than 3 levels in this analysis. So that's not an option. We're left with Bonferroni and SEDAC, and they're very similar to each other. SEDAC is slightly more powerful, but I think trying to understand when you can and can't use it might be a little bit more complicated for the typical researcher. So I probably just as a general statement recommend the Bonferroni. Now the Bonferroni is a single-step procedure, so I don't even really need the significant ANOVA to be observed first. I could technically just go straight into the Bonferronis to determine whether they're statistically significant. So let's check that out. And we can see that there's a table here called Pairwise Comparisons, pretty big table. So let me see if I can fit this all in the window. So Pairwise Comparisons, and we have exposure 1 and 2. So that's actually true in terms of the exposures, but you can see that this exposure 5, level 5, actually that should be 25 because when you look at the actual variables, it's exposure 1, 2, 5, 10, 25. Unfortunately, SPSS doesn't report it that way. It just says this is level 1, level 2, level 3, 4, 5. So you kind of have to keep in your mind that level 5 is 25 exposures, 4 is 10 exposures, 3 is 5 exposures, 2 is 2 exposures, and 1 is 1 exposure. And we can see here that a lot of these comparisons were not statistically significant. In fact, only the mean difference between exposure 1 and exposure 25 was statistically significant. The mean difference was negative 0.436 with a p less than 0.001. And this is Bonferroni corrected. So you can see the Bonferroni here, adjustment for multiple comparisons, Bonferroni. So I am protected here. And it's just basically saying that only the difference between this mean and that mean was statistically significant. All other comparisons with this mean were not. So it doesn't look like there are any statistically significant differences between any of these means, as you can see with all these p-values that are not less than 0.05. So the next one that's statistically significant is the difference between exposure 2 and exposure 25. I know it says 5, but again, that's really 25 exposures. That was statistically significant. The difference between 5 exposures and 25 exposures is statistically significant, p less than 0.05. In fact, it's 0.014. The difference between 4 and 5 is statistically significant. And finally, the difference between, I said 4 and 5. I should have said 10 and 25. Or is that 10? Let's double check here. 4 is 10. Yeah, 10 and 25. 4, 5, 10 and 25. And then it's just repeating itself, 5 versus 4. Yeah. So we can see that all of the comparisons with 25 exposures were statistically significant. So there's a lot of repetition in this table. It's just the way SPSS outputs it. It's probably a little bit unfortunate that it does that way, but maybe there's not really an easy way to report it otherwise. The summary is that all of the mean differences between 25 exposures and the remaining exposures were statistically significant, but there was no difference between any of these means when we used the Bonferroni correction. In fact, nothing was even close. So that is one way to do a multiple comparison procedure in SPSS, and it's not especially attractive. And I mentioned conducting a trend analysis in this study, but I cover that in the advanced topics if you want to go to that length of analyzing the data. And I seriously encourage you to consider doing something like that for a study like this one.